you shouldn't go into science if you're not basically curious about things. I mean, if you're someone who thinks the world's all very satisfactory and you understand it, don't do science. Go and be an actuary or something. It You have to be curious. You have to be impatient of current explanations and willing to sort of probe at them. And you have to like finding out things. You have to like actually turning things over. Because, what the guys who criticize climate scientists, for instance, miss is that what really drives scientists is showing that other scientists are wrong. That's one of the things that drives people. And it's not the main one, but, if you could find something that overturns what's regarded as the current paradigm, the current interpretation, that's terrific, and that's what really makes big scientific reputations. What do you need to be a scientist? Well, you need to be curious. You need to be well enough organised to run a lab and get grants, and you need to be able to write good English if you're going to get grants and write scientific papers. You need to be able to write clearly and communicate clearly, and you need to be pretty resilient psychologically, because every scientific career, everything goes up and down. You'll go through periods where things are fantastic and you're finding out all sorts of stuff. You'll go through periods where things are very flat, especially when you're first beginning, because you're doing it yourself, really, as part of the training process. You may be working as part of a group, but it's your project, and a project can go well or badly. With a big lab, of course, you have a lot of different projects going on, so usually something's going well and if the rest of it's not going too well. So you have to have the sort of organisational skills you need to do anything. You have to be impatient of hypocrisy and don't have enormous respect for the general wisdom. I mean, common sense, for instance, is really just what the accepted wisdom says. A lot of it can actually be extremely stupid. I think we have some enormous problems facing us, and some of those problems have to be tackled by behavioural modification. But as we all know, it's enormously difficult to get people to change their behaviour. So the only option we have apart from that is to try and do the best possible science, to try and seek solutions to some extremely difficult problems. We're going to have to feed a larger human population with what will probably be less productive land as a consequence of climate change, and we're also going to have greater weather variability, which will again impact on food production. So that means we need to move that whole area forward with science in ways that will produce, say, drought-resistant crops, in ways that perhaps will emphasize more growing food under controlled conditions, perhaps under glass or under some other material where it can be protected from extreme weather events. So we need a lot of science just in that area alone, and that's just one area. The other big area, of course, is energy, and we need a lot more science as well as technology development to generate clean and green energy for the future, and we need masses of it. The basis of science really is discovery, and I mean hypothesis discovery and so forth, and then measurement of whatever form to actually see whether what you're saying is useful. You can make discoveries anywhere. If you make a big discovery in the United States that, say, is going to impact on some new technology, that will be developed in the United States, and the United States will get the advantage of it. The same is true of China, the same is true of Korea or anywhere else. If you want to have new initiatives, you have to have discovery-related research. And in fact, you can't just do research targeted towards specific goals, because you'll do very boring research and you'll never find out anything because you may be targeting the wrong question. So discovery is extremely important, especially in biology, where you don't know what's going to be thrown up a lot of the time. If you simply take a current understanding and do nothing further and try to develop that to get a solution. You can be doing what Jim Watson described some years back as funding cannon builders to put a man on the moon. I mean, you have to have innovative and basic science. It just doesn't work otherwise. And if you go out of that business, then you're out of science. Yeah. I mean, it's all it's so obvious. Anyone with a brain can understand it. Yes, it's basic research. Yeah, I don't really divide research into different categories anymore, because with modern molecular science, the boundary between discovery and application can often be very narrow. I mean, if you turn up a molecular pathway or a molecular event or a structure that's extremely important in understanding what we call pathogenesis, that's how a disease develops, you may be able to translate that to a product relatively quickly. I mean, relatively quickly to a product that's pharmaceutical, for instance, is 10 years, and it's a lot of money. So I don't think the distinction there is all that useful. That there's a development is different from research. You know, once you've got something you think may lead to a product, that development process can be quite different and requires quite different types of skills and talents, and no less important than the people who make the actual discoveries. It's unusual for someone who makes a basic science discovery to take that forward to a really practical application. Again, I think these boundaries are increasingly blurred. And I don't sort of categorize them as separate types of activities. They are separate in a sense. I mean, the engineer who's building a new bridge, for instance, is not going to build a control bridge to see whether it falls down or not. I mean, you know, he's using best available technology to build the best available bridge. And so that's different from the process of science, where you're trying to find out something different. But I see them all as part of a continuum. And I think one of the issues for Australia, one of the things we got wrong actually, is to set up a separate science academy and a separate engineering academy. The two should have been together. And the more we can bring them together, the better. The Royal Society in England brings them together. The National Academy of Sciences in the US brings those two functions together, though they have a kind of subset of engineers as well.